We're on the bottom of page 3 for your chemical quantities note packet in empirical and molecular formulas. Now, we're going to take a few notes. We're going to do a little bit of practice. The empirical formula is the formula that represents the smallest whole number ratio. It is the simplest. Smallest, simplest is empirical. The other is a molecular formula. And it's the true formula. It's the actual whole number ratio of atoms in a compound. So we need to be able to go from empirical to molecular and molecular to empirical. We're going to do the second one first. Our examples say, write the empirical formula for each of the molecular formulas. Now we've got this, it's glucose. This is a molecular formula, which I'm going to write MF. And we're trying to get to the empirical. So we find our largest factor. In this case is 6. So we're going to divide each thing by 6. And we end up with C. 6 divided by 6 is 1. We don't have to write the 1. H2O. And that's our empirical formula. It's simplified. It cannot get any simpler. So what you're going to do is you're going to do the next two. Please press pause and come back when you're ready. Okay, so here are the answers. Now, one of the things that we need to talk about is, can a formula be both empirical and molecular? Let's take water, for example. Water is H2O. Is H2O the actual formula for water? Yes. So it is a molecular formula. Can it be simplified down any further? No, it is in the simplest form. So that means it's also an empirical formula. So please know that a formula can be both molecular and empirical at the same time. Now, we can use empirical formulas from the experimental data, which is what we're going to do on the top of page 4. So please turn your page. And we have 3 steps that we need to follow. They're written out right here. We're going to find the empirical formula GFM. We're going to divide the given mass, the molecular mass, by the empirical formula, and that should give us a whole number. And then we're going to multiply our subscripts by this number. And I'm going to do an example, and here are our 3 steps, and I have laid it out. And a compound has an empirical formula of CH2O, and a gram formula mass is 60. So we've got 2 very important pieces of information. What is the molecular formula? So the first thing we're going to do is we're going to find the GFM of the empirical. So we've got carbon, hydrogen, oxygen. We're going to do the same thing that we were doing for GFM. I counted. Now I'm going to multiply through by their masses. We're still not going to round unless it tells us to. Now please note, by this time in the unit you probably have some of these numbers memorized. Do not go by memory. People start dropping numbers. Make sure you always look them up. Now when I add these together, I end up with 30.02628 grams per mole. Next thing, we're going to divide the molecular mass by the empirical mass. The molecular mass was given to us in the problem. It has to be given to us. So we're going to take 60 and divide it by the number we just got. And we're going to round to a whole number, which is going to be 2. 60 divided by 30 is 2. Next thing we're going to do is we're going to multiply these subscripts. So I'm going to write it out. We're going to multiply each of these by 2 because that's the number we just got. So our final answer is C2H4O2. Now what I want you to do is go through and do the practice.